Cosmos 3 is the benchmark for world models this quarter because it's arguably the first fully open-source Omni model on the market. The deeper question is this: what reason do we actually have to believe that years from now, the models for so-called embodied AI won't come from the general-purpose model giants, Anthropic, OpenAI, or Google? If the Omni model path ultimately proves effective, then can a robot's understanding of space and its prediction of actions all be folded into a single, larger general-purpose model?
From the public information so far, can you tell what generalists' thinking on world models actually is?
They're actually fairly resistant to defining themselves as a world model or slapping on a VLA label. Peter Florence wrote a whole piece on this, the gist being that their approach is neither gluing actions onto a VLM to make a VLA, nor is it a world model. Fundamentally, whoever can supply reliable, stable, cheap dexterous hands the fastest will become the de facto standard for this industry the fastest, meaning more of the algorithms and software get designed around your hardware architecture. Hello everyone, welcome to the Alphaist Podcast. I'm Peter Chen from Alphaist. Alphaist is a new fund focused on hard tech. Our mission is to empower alpha founders to propel humanity forward. The Alphaist is an in-depth conversation show. We focus on the first principles of technology and entrepreneurship, highlighting early-stage entrepreneurs, engineers, and product explorers who are changing the world. This episode is our second quarterly crossover with LateTalk. So let's get right into it. Here's my conversation with Manqi.
This is the second installment of LateTalk's Embodied AI Quarterly, and we've once again invited Peter Chen, founding partner of Alphaist, onto the show. After last quarter's episode, a lot of comments asked for Peter to come back as a regular, so we'll keep this series going with him. Peter, say a quick hello to our listeners.
Hi everyone, great to be back.
So, as usual, let's start by recapping the most important top 5 developments of the quarter, a mix of industry events and technical milestones. Peter, for Q2, in embodied AI, or as people increasingly like to call it, physical AI, what are the 5 things you've been paying the most attention to?
What stood out in Q2 is clearly the breakthroughs in world models and dexterous hands, and at the same time humanoid robots entered the public consciousness at scale for the first time. Here's how I'd personally rank the top 5 in embodied AI for Q2. First, the Beijing E-Town Humanoid Half Marathon, where over 100 humanoid robots ran the full course. The marathon champion turned out to be the robotics division of the phone maker Honor. The signal here is that the big players can do humanoid robots well, and over the next stretch they may become a very important force in the whole market. Second, Figure ran a multi-day live stream of a humanoid robot doing package sorting. This was the first time the value of humanoids in industrial settings got broadly demonstrated and explained to a global mainstream audience. Third, the explosion in dexterous hands and dexterous manipulation. At ICRA in Vienna this year, companies led by Wuji released a new generation of high DOF dexterous hands, and a number of embodied AI startups built fine manipulation foundation models on top of high DOF hands, making dexterous hands the next competitive battleground. Fourth, on June 1st, NVIDIA released its latest world model, Cosmos 3, turning world models from a concept into a genuine product and a paradigm benchmark, and the hottest startup wave of the quarter. And the last one that left a deep impression on me is the further iteration of the VLA line. Physical Intelligence shipped Pine 7, and Generalist shipped Gen 1. Both pushed the capabilities and the narrative of VLA further, and we started to see signs of them merging with world models.
Before we dig into these 5, let's revisit the end of last quarter's episode. We discussed some forward-looking calls back then. You listed phenomena you thought might show up this quarter, or over a longer horizon. The first one was about whether world models could deliver progress that goes beyond VLA. So quickly, do you think that happened this quarter?
Last quarter, when we talked about world models, it was still a very research stage, conceptually innovative idea, or at most we'd seen some early lab-grade prototypes.
And what we actually drilled into back then was world action models, which you could call one subcategory within the broader world model umbrella.
Right. For example, the NVIDIA Dream Zero we mentioned then was actually a fairly small-scale lab project inside NVIDIA's Gear Lab, and the video model it used was still the open-source WAN 2.1. But by June, the Cosmos 3 that NVIDIA released was a much more product-grade, much larger pre-trained model. I'd say it pulled the concept of world models from the lab to industrial grade, into a state where it can actually be called and deployed.
Right. And you can see that from the release itself. It came in 3 versions at once: Super, Nano, and Edge, targeting different deployment environments. We can come back to that. But to the question, would you say world models delivered competitiveness beyond VLA?
I think the strengths and weaknesses of the classic VLA architecture are already pretty clear. The strength of a world model is prediction and modeling of the environment. With Cosmos 3 as the representative, we've seen a unified architecture world model that could potentially lift VLA's capabilities, and we've also seen leading VLA models pulling in or stitching in world model capabilities through various methods. So rather than saying world models disrupted or surpassed VLA, I'd say world models gave existing SOTA models a new capability and a new way of thinking.
The other 2 things you said you expected and thought would likely happen were more results in Dexterous hands and manipulation, and your call that the second marathon would shift the overall perception from gimmick and comedy toward more serious competition. So back to the top 5. The first item is the Humanoid Marathon held in Beijing on April 9th, not long after we recorded last quarter's episode. You mentioned the top 3 were all Honor's robotics division, their robot Lightning. First, second, and third were all the same robot. First question, did this surprise you or other people in the field?
I was at the Yitang Marathon in person that day. Before the race, the 3 favorites to win were Unitree, X-Humanoid, and Honor, so the market did anticipate Honor's strength.
Why did the industry consider Honor, Unitree, and X-Humanoid the favorites before the race even started?
Because last year, X-Humanoid's Tiangong robot was the defending champion, and they'd done a lot of prep for this year's race. Unitree didn't officially compete last year. This was their first official entry. As the current global benchmark in humanoid locomotion, expectations for Unitree's performance were very high. They'd put out some test videos beforehand showing real strength, hitting 10 meters per second on the test track. Honor's robotics division was set up about 2 years ago with a team of close to 100 or 200 people, and they recruited a group of engineers and experts with deep humanoid experience from across the industry. Their investment and R&D spend for this race was substantial, by an order of magnitude, clearly higher than the other 2. What did that money buy? It let them custom build the high torque motors the race demanded and design a very precise liquid cooling system. There was a very obvious situation on race day, which you could also see in the live stream. Other companies' robots would overheat under sustained high-speed running and have to rest. Because Honor designed a better liquid cooling mechanism, they kept motor temperatures across the whole race at a relatively low level. That's a key reason their Lightning robot could maintain such high speed and consistency throughout the marathon.
Honor's win actually raises a question I think is tied to where the industry is headed. Some people argue that this year, for the companies whose strength is the robot body itself, a key hurdle is whether they can IPO and reach a relatively safe, well-resourced position. If they can't, then over the next year, say 2027, the big terminal device makers with deep resources like Honor, including phone makers and also car makers, might bring their own robot bodies to market. And these companies have far more experience in large-scale manufacturing, reliability, and consistent execution. How do you see that view?
I think this marathon actually proved one thing. A team with high-end manufacturing experience and strong organizational capability, given enough resources and talent density, can quickly produce a very competitive humanoid robot.
That's more on the hardware side of the product, right?
Right. But on locomotion, navigation, and other capabilities and algorithms, the big players aren't behind either, at least for a marathon, which is purely about performance. Honor's capabilities are no worse. The implication, I think, is that China has quite a lot of incumbents with Honor's level of organizational capability, talent, and capital. EV makers and phone makers like Xiaomi, XPeng, and Li Auto have already started investing seriously in this humanoid game. So I'd argue that humanoid robots, as a high-end manufacturing business plus a complex systems engineering challenge of algorithms and software, are shifting from the lens of single technology startups toward a contest of systematic engineering and systematic operational capability. Honor's success in this marathon is, in a sense, a preview of what the competitive landscape of this market might look like.
I also have a small question about the rules. Since first, second, and third were all Honor robots, does that mean one manufacturer can field a lot of robots this year?
Yes, and that's exactly what I meant. Compared to its 2 rivals, Honor had far more abundant resources to put into the race.
So X-Humanoid and Unitree each fielded only one?
If I remember correctly, The other companies fielded 2 or 3 teams each, but Honor entered 10.
There's no cap on that? No constraint?
The race is first split into remote-controlled and autonomous navigation categories, with several teams in each. Because Honor had enough resources and brought enough units to enter both categories, they won the championship in both.
Let's talk about the actual results too. In 2025, the champion was Tiangong X Humanoids team, and back then the half marathon was finished in 2 hours 40 minutes. Second place was Notix Robotics, already way behind at 3 hours 37, an hour's gap. This time in the autonomous navigation category, Honor's 3 robots, first, second, third, all came in around 50 minutes and tightly bunched. Plus, last time those 2 were remote controlled, and this time it's autonomous navigation. How do you assess this pace of progress?
First, I think the pace is very fast. In roughly a year, the time improved more than threefold. And over such a long distance, with multiple robots racing, they achieved a high degree of reliability and consistency. Compared to last year when a lot of machines were stumbling along, this year they could finish the whole course fairly smoothly. We're seeing very fast progress at the hardware level, the control level, and the autonomous navigation level. There's another layer of meaning. I think if people seriously go optimize a problem and put in the resources, a lot of problems are solvable under today's technical architecture. The bigger issue maybe was that there had never been a demand pushing humanoid locomotion to its performance limit, so we wouldn't go and optimize the entire hardware and system for, say, a marathon environment where you're racing top speed for over an hour.
But in a format like a marathon, it does create a demand, just not a market demand. And that's the long-standing question people have about these competitive or performance-style demos. What's the point? I optimize it really hard, and then what?
I think a marathon, as a test of extreme athletic performance, is essentially a proving ground for humanoid robot technology.
It's a benchmark, you could say.
Yes, it's like F1 racing. It was never about selling cars. It's where different automakers show off their latest tech and what they can pull off pushing the technical envelope, and a lot of that tech gradually makes its way into production cars or products. For a humanoid to complete a 20-plus kilometer half marathon, it needs excellent whole-body locomotion, the ability to handle high-stress situations and all kinds of irregular obstacles on the ground, plus very long fault-free operation, while solving power supply, heat dissipation, and a whole stack of system-level problems. A marathon basically creates an extreme test environment. Once we know the boundaries of a humanoid's various capabilities cold, we'll have a ton of system and design experience to draw on when it's time for mass production.
Next, let's discuss your second development, Figure AI's livestream demo. It's also a demo, but unlike the marathon, it took place on a real logistics line. Let me set it up first. Starting May 13th, 3 Figure robots livestreamed for over 100 hours. The package sorting task was basically standing beside a conveyor line and, as each package comes by, flipping it over so the label faces up. You can check the photos and video links I've put in the show notes. Over those 100-plus hours, they sorted 130,000 packages total, roughly 1 every 3 seconds, and they ran it against humans too. There were human workers doing similar work, with comparisons on cadence and success rate. So why did you put this in the top 5?
Figure's package picking work this time, both in terms of visual appeal and actual industrial value, counts as a 0-to-1 breakthrough. For a long time, we've been debating what kind of work can humanoids actually do? In what settings can they effectively replace people? I think logistics package sorting is a perfect fit. It needs some generalization and general manipulation ability, and the work itself is continuous, long duration, and deeply unsuited to a human doing it for hours. Figure is the first company in the world to demonstrate a scenario like this to a global mass audience via livestream. The demonstration value is very clear.
In the clips I watched, the robot didn't actually move. It stood in a relatively fixed position, but it used a full humanoid with 2 legs and 2 arms. Do you think that's overkill? It really only needs the manipulation ability.
Let's unpack the scenario. In package sorting, packages come down a conveyor fast. And yes, in the vast majority of cases, all you need is to pick up with 2 hands or flip the item over, which is why Figure is fixed in place there. But in reality, plenty of accidents happen. The conveyor moves too fast, the item is too light, or it's spherical, or it slides.
It could fall out.
It could fall out. And once it slides out or hits the floor, and we did see 1 or 2 clips in the live stream where an item slid off the surface onto the ground, when these accidents happen, a human knows how to handle them.
To manage the edge cases, but the robot didn't get to that in the live stream, right?
Not yet. But the point I want to make is why this scenario needs a humanoid, or is best done by a humanoid, because when these accidents actually occur, only a humanoid, plus the generalizable capability of today's embodied models, can solve this kind of unbounded long-tail problem. Which brings us to another question some friends might raise. Didn't machine vision plus industrial arm companies try to solve this exact problem 4 or 5 years ago?
Right, that's exactly what I wanted to ask. China Post, in fact, has been working with a lot of Chinese robotics companies over the past 4 or 5 years on the very approach you're describing.
That specific problem was never actually solved.
So it was mostly demos before?
No real industrial deployment. The old approach, motion control plus deep learning image recognition plus an industrial arm, really struggled to solve this well. What problem are we solving? When the package comes down the line fast, we want the side with the QR code or barcode to be scanned quickly. But a courier package is often soft, and the QR code stuck on it is easily occluded or deformed. If a human does it, they use 2 hands for dexterous manipulation, flipping the code face up and flattening it. Those 2 actions were basically unsolvable under the tech stack of 4 or 5 years ago.
So it also demands a lot of dexterity and precision from your end effector.
Right? Which is why in the demos from both figure and robot era, you see a dexterous hand. As I said, the companies trying to solve this 4 or 5 years ago were basically still using suction cups, not even grippers, because under that era's tech stack, suction was the more general solution. But you've basically never seen a 2-handed suction cup setup. It can only do simple pick and place.
Is there also a difference in scenario difficulty? In some logistics settings, the packages may be more standardized, with fewer soft packages, mostly rigid cardboard boxes and such.
Sure, including companies I've invested in, like Hi Robotics and the already public Geek Plus. These warehouse and logistics automation robotics companies are all solving standardized logistics scenarios. But why is logistics still such a large, valuable use case for humanoids today? Because beyond the standardized packages and standardized boxes, there's a huge volume of non-standard packages and picking needs that remains unsolved.
E-commerce warehouses, for instance, I think that's a pretty typical scenario, because some e-commerce warehouses have hugely varied product types, and the items are also quite soft and irregular.
There's picking, there's packing, and there's sorting like courier handling. Figure and robot era chose this use case very smartly because it's genuinely a problem the old tech stack and the non-humanoid approaches struggle to handle cleanly. It's like the cloth folding demos we saw earlier from Pine and Dyna. Manipulating deformable materials is exactly the kind of problem today's embodied models are well suited to solve.
What does deformable mean?
Materials that can deform and change shape, soft things, textiles, plastic bags. You can't model their spatial geometry and contact points with a simple, rigid body model, so you need a model with some generalization and understanding, an adaptive model, to do this kind of dexterous manipulation.
Back to Figure AI's live stream, there was a controversy. In some clips, the humanoid made a head-touching motion, and people said, "Isn't this teleoperated?" Figure AI officially said the live stream was done autonomously by their Helix O2 model.
I don't think teleoperation is the real point of contention at all, because I believe every humanoid, before it truly enters a deployment scenario like this, goes through a long phase of teleoperation to collect data and correct actions. Even if a meaningful chunk of the time requires human intervention, I don't think that diminishes the significance of the thing itself.
Speaking of which, it makes me think, in the future, when it really enters long-term industrial deployment, it might look a bit like autonomous driving. There's a human in the back office managing, say, several robots, because situations come up that need a person to take over. Take over efficiency. How many can one person monitor, right?
Of course, remote takeover is already a market norm for robotaxi systems. When we look at Waymo and other robotaxi companies, we always measure their
Takeover efficiency. How many can one person monitor, right?
right. And I think the same will absolutely apply to a fully autonomous humanoid.
But that raises another issue. In industrial, logistics, and production settings, you can have one person watching the back office. But if you really go into the home, there's a privacy issue, right? So doesn't that raise the bar for the robot's full autonomy even higher?
You could put it that way. That's exactly why the difficulty of humanoids truly entering the home, from a privacy standpoint and a data distribution standpoint, is greater than in pure industrial settings, which is why I think the logistics sorting scenario Figure found is a really good one. If you look at the B2B robots that genuinely succeeded historically, they were basically all in settings with large-scale deployment volume, high enough throughput, and fairly consistent work environments and requirements. The very successful B2B robots I mentioned, Geek Plus, High Robotics, Kiva Systems, were all in warehouse automation. We've also seen some humanoid companies trying to do deployments and demos in industrial settings. But if you look closely at those scenarios, some of the deployed humanoids are doing things that dedicated robots and dedicated arms can already do, essentially very precise loading/unloading and tool positioning tasks. Whereas the scenario figure demonstrated, I'd argue, was not well solved in the earlier machine vision plus industrial arm era.
Last year and this year, Unitree and some other robotics companies appeared twice on the Spring Festival Gala, which gave the Chinese public a lot more awareness of humanoids and stirred up a wave of interest. Do you think Figure AI's live stream crossed over overseas? Did it reach a mainstream audience?
I think the response on X was pretty strong. Around the same time, something interesting also happened on America's Got Talent. A dancer from Chengdu, Sichuan named Yufei Wu performed a live dance with 8 Unitree G1 robots and got an enthusiastic response from judges and audience, plus a golden buzzer level all-in vote to advance. After that video came out, it sparked a huge online discussion. Like Figure's demo, it let ordinary Americans see, in a very intuitive way, how humanoids are starting to enter industrial and commercial settings. Before this, many people had seen the Spring Festival Gala robot performances on YouTube and Twitter, and a lot of them doubted it. Is this AI generated? Was this recorded over many takes rather than a live broadcast?
Let's come back to China. As mentioned earlier, Robot Era has also announced some new logistics partnerships with China Post. Back in November last year, they'd already shown a postal package sorting demo. How far do you think these developments in China are from real deployment?
In terms of technical maturity, it's already at a fairly mature stage. My information is that Robot Era, in courier sorting, has run long-duration testing and training not just with China Post, but also with SF Express. They can already do fully autonomous sorting, flipping, and scanning the whole sequence of steps on a humanoid. It's a great illustration that Chinese companies' real-world progress on humanoid deployment in logistics and industrial settings is in no way behind that of US companies.
Once a scenario like this gets out there, once the operators of these use cases have this demand, will a lot of companies rush to try it? Besides Robot Era, whose partnership we've already seen announced, do you know any other companies investing heavily in logistics?
I'm not sure exactly which companies will pick this use case, but what I do know is that this is a good PMF. It suits a dual-arm humanoid. It suits an embodied model with some generalization and intelligence, and it also needs a dexterous hand. So there are surely plenty of teams with that combination of capabilities.
Companies you've invested in before, like High Robotics, and others founded earlier like XYZ Robotics, have been deep in logistics for a while. Do you think they can expand in this direction?
I think they can. This goes back to a very fundamental issue for enterprise tech companies. Very little of the technology itself is monopolistic. What matters more is that your product or system has to embed into a larger operational system. Here it's courier or warehouse logistics automation. The industry-specific domain knowledge you hold and the coupling with the customer systems both become very important barriers and moats for an enterprise tech company. So I'd argue the enterprise robotics companies that already found some success in the previous paradigm all have a shot at applying humanoid and embodied brain capabilities to scenarios that remain unsolved.
The earlier batch of companies has one disadvantage now, is their fundraising relatively weaker because they don't seem to have a strong new hook for raising, even though they already have meaningful revenue.
The earlier wave of enterprise robotics companies has basically all entered IPO or pre-IPO. Even if in the primary market telling an embodied AI story makes people see them as old companies, the reality is that once they actually IPO, the resources and capabilities they can access may be far greater than companies still in the primary market today. Take Pudu, which used to make food delivery robots. They're now a top player in commercial cleaning. Or Geek Plus and High Robotics, which have already used their mobile robots to solve a huge range of automatable scenarios in warehouses. But warehouses still have lots of workers, and property management still has lots of cleaners and staff. For all the scenarios that today's simple automation hasn't covered, those are great extensions for these enterprise robotics companies.
On overall humanoid progress, last time we also discussed a sub-trend, combining locomotion motion control with manipulation, that is whole body motion control. As mentioned earlier, a task like package sorting needs whole body control in some corner cases. I've noticed a change. There are new companies founded specifically to do this. For instance, Archon Robotics, founded by Hongyang Li.
Right, Over the past 2 or 3 years, the embodied market has indeed mostly focused on manipulation intelligence. When we talked about a robot's locomotion before, we naturally think of it as a cerebellum capability, unrelated to the brain stuff like cognition, decision-making, and manipulation. But as locomotion and manipulation techniques have matured, we now find there's an opportunity to use a more unified architecture to train movement and manipulation together. Under that premise, the value of teams with genuinely strong motion control capability gets amplified. This quarter, we didn't just see a lot of new startups emerge. I also saw a clear trend in data collection. More and more companies are collecting whole-body locomotion data.
Whole-body locomotion data. Can you talk about what kind of data people used to collect and how it differs from before?
Let me walk through the evolution of data collection paradigms. We know the overall bottleneck in embodied AI is data, and each cycle's shift in model paradigm is essentially a shift in data paradigm. By watching what the data collection companies are doing, we can also anticipate where the industry is heading. Go back 2 years. The hottest direction then was Aloha, which is essentially real robot teleoperation for data collection.
Aloha is a lightweight arm setup, you could say, real robot teleop, lightweight dual arms for collection.
The classic Aloha setup actually involves 4 robot arms. A person operates 2 of them, directly controlling the other 2.
So the configuration is identical.
It's isomorphic. Every motion we make on the teleoperated arm can be cloned and replicated by the other arm. That was the main data collection approach about 2 years ago.
This approach was proposed by Tony Zhao, another co-founder of what became Sunday Robotics back at Stanford, right?
Right, work that Tony and Zupeng published in 2023. Then around the last year came the Me approach, built by Cheng and team. A person holds a 2-finger gripper, an embodiment-free data collection method.
So the upside is lower cost.
Right, it doesn't need a real robot. A data collector can just hold 2 grippers and collect in lots of real-world settings. By late last year, people also started bringing in egocentric video, often with a head ring or head-mounted camera, to collect tons of first-person manipulation footage. The biggest advantage of this approach is that diversity explodes. It can be used across very broad settings, with minimal interference to the person doing the task.
Does the egocentric approach need to be paired with gloves, or not necessarily?
Not necessarily. Its core feature is first-person video. On top of that, it can be egocentric video plus 2 Woomi grippers, or egocentric video plus a Dexterous hand data glove, or bare hands.
So both the volume and the diversity go way up.
Yes, by late last year, with the arrival of NVIDIA's Sonic full-body motion capture work, more and more teams could use mocap to do large-scale data collection for humanoids and migrate a person's various movements and dances onto a humanoid faster. That's why, this year, we've seen more attempts at full-body mocap and at doing manipulation work on top of full-body mocap.
NVIDIA's full-body mocap, Sonic, how does it differ from the special effects mocap we sometimes see in films and documentaries, where they put lots of dots on a person?
Essentially, you have some rough skeletal points, maybe captured with external cameras, and you need to map those skeletal points onto a humanoid body. That's the retargeting. Sonic is an open-source tech stack, and because it's done so well and is so simple, people can migrate to it quickly. A big reason is that Unitree did the work, and not just on hardware. In the open source community, lots of people optimize parameters around the Unitree G1, so when we capture a person's skeletal motion data, that motion can be migrated onto the Unitree G1 very quickly.
So algorithmically, it's tied to the open source results of NVIDIA's Sonic, and on hardware, it's that Unitree's robot body has gotten more mature, so this year more people can explore whole body motion control.
Right? Or from a researcher's perspective, they'll always want to do something newer, more exploratory, more ultimate. That's why we see not only a lot of full-body data collection and mocap approaches aimed at manipulation, but also a lot of companies starting to figure out how to collect dexterous hand data, whether via gloves, exoskeletons, or other methods. Fundamentally, the data we start collecting today may translate into model breakthroughs 3 or 6 months from now.
That brings us nicely to the third topic, dexterous hands and dexterous manipulation. You just got back from ICRA in Vienna, the International Conference on Robotics and Automation. Wuji had a sizable presence there too. Can you talk about what changed for dexterous hands in Q2, including the latest feedback and discussions from ICRA?
A lot of Chinese manufacturers exhibited at ICRA this year, especially in dexterous hands. Led by Wuji, they released a new generation of direct drive dexterous hands. Companies like Zenova and AGLink also released their new generation high DOF hands. drawing a lot of attention on the floor.
Linkerbot and Sharpa went too?
Sharpa didn't release a new Dexterous hand product. Linkerbot did attend.
Did Robot Era show a hand at ICRA?
Yes, Robot Era's high DOF Dexterous hand was also unveiled.
Right, among the companies that do both the body and the intelligence, they make their own Dexterous hand. Their China-Post partnership also used their own hand, the X hand.
Right, that's probably a mid-DOF hand, but what they unveiled at ICRA was the 21 DOF flagship.
So that's high DOF.
Quite a few companies unveiled Dexterous hands at ICRA, but of all of them, Wuji's second-gen hand clearly drew the most attention and recognition. This year's ICRA was a lot like 2025. The biggest impression in 2025 was Sharpa unveiling its high DOF hand, and this year the deepest impression for most people was probably Wuji's second-gen hand.
Can you walk through the basics of Wuji's second-gen hand? For instance, last episode we talked about Sharpa's hand being 22 DOF and priced around $50,000. At the time, a lot of frontier embodied research labs were using it, or waiting for it.
Right. Wuji's second-gen hand is also 20 DOF.
20 DOF?
Yes. Some Dexterous hands may claim higher DOF, but in reality some of those degrees of freedom have no actuation behind them.
So one joint is driven by another joint?
Right. Generally, we split a Dexterous hand's DOF into active and passive. Some are passive, nominally higher DOF, but those degrees can't be actively controlled. They just get dragged along when another joint pulls on them. So for a high DOF hand, around 20 DOF basically covers the in-hand manipulations humans need. It's also an engineering trade-off. Fundamentally, a full DOF Dexterous hand depends on whether your approach is direct drive or tendon-driven, and the engineering difficulty differs. For a full DOF direct drive hand, it's basically a motor on every degree of freedom.
You said Wuji got a lot of attention at ICRA. What capabilities did it show to earn that?
Wuji and Sharpa are probably the two most advanced companies globally at direct drive high DOF hands. Their first-gen hands last year got a good market response, but a lot of engineering problems went unsolved. For instance, serious heat issues. And the first-gen structure had no back-bending capability, meaning the joints couldn't freely bend backward, so under high-impact conditions it was prone to damage, and the joint's response to and control of force wasn't very sensitive. This second-gen hand, without adding weight, achieved better back-bending performance and greatly improved heat dissipation. So on the floor, their booth had tons of visitors trying the hand themselves, feeling its dexterity and back-bending, and that's very appealing to a lot of researchers.
Appealing?
Right, and if you put Wuji's hand side by side with Sharpa's, you'll find Wuji's is only about half the volume of Sharpa's. So for simulating the size of a real human hand, Wuji's advantage is very obvious. Basically, high DOF hands, except Wuji's and Zenova's tendon direct hybrid, tend to be 1.5 to 2 times the volume of an adult human hand. That creates a lot of problems. It means many manipulations you can do with a human hand, if you learn the policy from humans, can't be reproduced on an oversized hand.
Did they show any flashy capabilities this time? When researchers look at this, how do they tell what's good? How do they judge whether it's what they need?
Mainly, they look at the hand's volume, agility, backbending, and the mechanical performance. It's the same as how we look at Unitri's robots. People need a good hardware platform so they can do a lot of control work on top of it.
I think this also relates to the difference in the two companies' positioning. We discussed last time how Yifan Li and team, restarting Sharpa, have a bigger long-term goal, to do general embodied intelligence entering through the hand. So they do a lot of their own software and algorithm work too, including a 3-layer model architecture they proposed, which is why they'll show things like assembling a pinwheel or peeling an apple with 2 hands. Is Wuji more like what you mentioned last time, that within Dexterous hands there's an opportunity and niche like Unitree G1, becoming the infrastructure for a lot of frontier research?
Right. Why did Wuji get a fairly positive response at ICRA? Partly because ICRA is mainly an academic conference. This is something I've picked up from many overseas researchers over the past year or two. After finishing gripper-centric VLA research, people found that hardware limits make many more complex tasks impossible. Dexterous hands aren't a new field. They've been developed worldwide for 30 or 40 years. But even today, there's no especially mature or cheap hardware solution that lets researchers everywhere do fast research and trial and error on top of it. I think Wuji's positioning today is a lot like Unitree's, focused on making a low-cost, high-reliability, stable hardware device that's reliable and durable enough for people to do tons of research and experiments on. That's why over the past month or two, we've seen so many startups, both US and Chinese, release Dexterous manipulation models or progress built on Wuji's hand.
What's the global market size for high DOF Dexterous hands right now?
Let me first explain today's Dexterous hand market structure, which splits into low DOF and high DOF hands. Low DOF hands, whether from third parties like Linkerbot or Brinko, or self-made by companies like Ajibot, today add up to a market of maybe tens of thousands of units a year, roughly proportional to the number of humanoid robots.
Do you know who sells the most in this market right now?
I think Linkerbot is probably the big one, but there's also Inspire Robots, which does linkage-based hands. Their volume is large too, since a lot of them started in the disability market early on. In low DOF hands, quite a few companies already have meaningful shipment volume, including Inspire Robots, Linkerbot, Brainco, OY Motion, and others, plus AgLink, which spun out of Agibot. The big scenario for low DOF hands today is really to accompany humanoid sales, whether for performances or simple grasping and pick and place. That's one market. In high DOF hands, led by companies like Sharpa and Wuji, the focus is the global dexterous manipulation research market. That market's shipment volume is still fairly small today, because before Sharpa actually went into mass production last year, there were basically no mass-produced high DOF hands you could buy. And although high DOF hands ship in small numbers today, the leaders at the level of a few thousand units, because the technical bar is high and they influence both algorithms and data, they're a competitive focal point.
That was progress on the Dexterous hand hardware. What about progress on Dexterous manipulation models, the more software or system side part?
In May this year, Genesis released a Dexterous manipulation model using a custom 5-finger hand.
Can you say a bit about this company? We haven't talked about Genesis before.
Genesis was founded in 2024, initially doing robotic simulation environment work, and a bit over a year ago shifted to focus on dexterous manipulation and full-stack robotic system development. I think the work they released in May represents a SOTA performance for dexterous manipulation with a high DOF hand on the market today. They publicly said they collected around 200,000 hours of data. I believe a good chunk is egocentric, with some real robot dexterous hand data via teleoperation or data gloves. From their demos, you can see they used Wuji's hand to pull off some very dexterous manipulations, solving a Rubik's Cube, handling food and cooking, playing piano, a whole range of relatively dexterous operations.
The cooking capability they showed has a pretty long sequence, 20 steps, a full dish, from prep to cooking. What kind of approach do you think that is?
I think dexterous manipulation models are still at a fairly early stage. A lot of today's dexterous manipulation is analogous to using Aloha for real robot teleop 2 years ago. What do I mean? If we have fairly high quality data of a human completing a task, whether via mocap gloves, exoskeletons, or other means, once we collect enough data volume, we can reproduce that action with high confidence and reliability. That's behavior cloning. Because there was previously no supply of high DOF hands at all, many model research companies today are still at the relatively primitive stage of acquiring real robot data. Later, as egocentric video techniques improve, or lighter Wumi-style methods let users collect high-fidelity hand manipulation data more quickly, we may train more generalizable, more general dexterous manipulation models. But today, companies like Genesis and many others doing dexterous manipulation are still in a paradigm a lot like doing Aloha-style behavior cloning 2 years ago.
Cloning human behavior. So if it switches to a different task, or the environment varies a bit more, the success rate might change noticeably.
Possibly. If we compare with Generalist, which has already gotten fairly general and generalizable at gripper manipulation, I'd say Generalist has found a way to collect hundreds of thousands of hours of embodiment-free data via the Wumi approach. For high DOF dexterous hand manipulation, the market doesn't yet have a clear method for getting data with high enough fidelity to drive a dexterous hand. Whether pure egocentric video only can solve it, or whether, like the early G1 dancing, we use a really good simulator like Isaac Sim, or whether we need really good mocap gear, be it gloves, EMG armbands, or other external exoskeletons, I don't think there's a clear consensus yet. But what we do know is only when the data problem is fully solved and unlocked will it be possible to train a truly generalizable general dexterous manipulation model, and the industry trend is pushing fast in that direction.
My next question follows from that point. Collecting dexterous hand data. Data is one of the 3 pillars of AI progress. So for an asset this important, where do you think the data ultimately lives? With third-party companies? A lot of hand makers may be third parties, versus a company that builds the full humanoid body directly. This question is also equivalent to another: who's best positioned to build dexterous manipulation fastest and best? Is it a company making the dexterous hand hardware directly, integrating hardware and software, iterating faster, or a company building an embodied brain, or a unified model fusing brain and cerebellum?
Your first question is who provides the data, right? The second is who provides the intelligence.
Right, because data and intelligence may be tightly linked, they're connected, or you can reason backward. For some companies, if intelligence is the must-win, then they have to own the data themselves.
We've observed the phenomenon in the real robot teleop Aloha era and the embodiment-free Wumi era. A lot of data collection companies were born, starting to serve various embodied AI giants and startups.
For instance, GenRobot is a standalone company.
Right. The US has some similar companies and China has some.
Light will too, right?
Right. Take Wumi, its dependence on or constraints from actuator hardware are fairly low because it's essentially a simple parallel gripper. But for high DOF dexterous hand data, if you don't control the hand's own structure and design, then as a third-party collector you may be heavily constrained by the specific body morphology and structure you want to map to, because a lot of the DOF and joint characteristics aren't easy to transfer or retarget.
So if I'm a third-party data collection company serving customers A, B, and C, I probably can't use one setup and one dataset for all three. I'd need some customization for each.
I think it's mainly because today's dexterous hand hardware structures haven't fully converged. As a data company wanting to collect dexterous hand data, the most basic question is which hand's configuration, which hand's DOF do you collect against? As we said, some companies are 22 DOF, some 20, some 21, which means the DOF design and structure on each finger differ.
So earlier when I asked where the data lives, I was thinking of two possibilities. Either the dexterous hand company does it itself, or the body maker self-develops the hand hardware and collects the data itself. What you're describing now is a third possibility, a company that purely does data collection and doesn't even build the hand itself. The hand might come from customers, from the data demand side, or from devices it buys. You're saying that's the possibility. You think it's hard, but it exists.
Uncertain. The data service provider niche does exist. In the large language model era, there were independent data service companies.
Right, embodied AI has some now too.
But in the future, if a lot of it is dexterous hand manipulation data, will the niche still exist? Or will they also need to build a very deep coupling or binding with the dexterous hand companies? That's hard to generalize.
Of the two possibilities I mentioned, which do you lean toward? Body makers have the incentive to self-develop the hand and get the data, or the hand company gradually enters through the hand and does more, beyond hardware, more data and software.
The logic is this. Dexterous hand-related data depends heavily on the hand's own structure and configuration, motor selection, and sensor selection. So this data for now is highly dependent on the dexterous hand itself, which means if you're the dexterous hand maker, designing your own data collection rig and standard makes a lot of sense. A third party really struggles to do it well directly. But the more critical question may be, long-term, what's the relationship between dexterous hand companies and humanoid body companies?
Or just call them humanoid companies, because those folks may also do the brain, the kind of company that does both the brain and the body.
Right. For now, it looks like humanoid companies will most likely end up full stack.
Full stack humanoid companies.
If they're full stack, they'll most likely want to do the body, the brain, and the dexterous hand themselves. The core challenge is whether there's still a slot for a broad, very large third-party dexterous hand maker. That, I think, is the more critical question. If that slot exists, then a lot of the data is likely supplied by these independent hand companies. If it doesn't, the data should come from the humanoid body makers.
I try to find an old analogy, but dexterous hands are genuinely hard to analogize. They're both a sensor and an actuator.
And their requirements on data format and standards are pretty high. Let me give an example. With LiDAR, a lot of vendors' algorithms don't actually depend on a specific LiDAR model or configuration. Point clouds from different LiDARs can be trained into a larger model through one pipeline. So LiDAR companies never got much say over the data. But dexterous hands are different. The data dimensions and format are closely tied to the hardware and solution design, and the market has no especially mature solution today. We also know the engineering complexity of Dexterous hands is very high. Musk keeps saying the Dexterous hand may account for 50% of his whole company's engineering investment. The result is that a lot of companies simply don't have the ability to build a truly SOTA hand on their own body. If that's the case, then is a third-party company actually better positioned to collect more data and serve more body makers? If we compare with autonomous driving, besides top players like NIO, XPeng, Li Auto, and Tesla that have full-stack capability, a huge number of companies still buy NVIDIA's or Horizon solutions, and NVIDIA and Horizon provide a complete autonomous driving stack that also covers data cleaning, collection, labeling, and training. So when we discuss the long-term relationship between Dexterous hands and humanoid bodies, it may be a long-term game of competition and coexistence.
On Dexterous hands, there's another topic we discussed last time, and I think it'll keep coming up, the choice between tendon-driven and direct drive. You also mentioned a Chinese company at ICRA, Zinova Future, doing a hybrid approach. And Optimus had a Q2 development too. The third generation G3 gradually disclosed some technical details, including that the hand is a 22 DOF dexterous hand, still using a tendon-driven approach.
Right. Another important release at ICRA this time was Zinova's Flex 2, a hybrid approach dexterous hand.
What's Zinova's background?
Zinova is a company with in-house capability in electric cylinders and core robot joint components. On that foundation, they've built 2 generations of dexterous hands, and one unveiled at ICRA this year is a very innovative hybrid drive high DOF hand. The hybrid shows up in this. The heavy load capability is delivered by motors in the forearm via tendon drive.
Heavy load means what? Gripping or grasping?
Right, grasping, the bigger forces, because the motors can sit in the forearm, where there's more space. And inside the palm, they also have micro motors that provide the more dexterous fingertip joint manipulation.
So the finger joints are direct drive.
Right? Which is why they call it a hybrid, a tendon plus direct drive approach.
So other makers demo starting from the wrist, while their product demo starting from the forearm.
So in principle, this approach could have the advantages of both tendon and direct drive.
And in principle, the disadvantages of both too?
This may get at a bigger problem with tendon drive. What's its inherent weakness? Why even today haven't we seen widespread high-speed dexterous hands ship using tendon drive? Zinova's hybrid tries to solve some of the problems pure tendon faces. To achieve high DOF, pure tendon may need a great many tendons threaded through a very narrow wrist space, and the assembly and maintenance are huge headaches. With a hybrid, you can replace some tendons with motors inside the palm, so fewer tendons have to pass through the wrist, and some DOF are delivered by the in-palm motors.
So its dual advantage is greater gripping force, while also being less complex than before, having mixed in direct drive.
Right, because the motors can sit in the forearm. Some bigger motors, freed from volume and heat constraints, can go in the forearm. If we think about the real structure of the human hand, our gripping force comes largely from forearm muscles, but we also have small muscles in the palm that control fine movements.
Speaking of which, it makes me think of a company, Origin Flow.
Right, an EMG company.
Their EMG data collection is a closed-loop armband worn on your arm, capturing some of your hand manipulation data via EMG signals.
Right, using EMG to control a dexterous hand or to capture human hand data isn't a new idea. Over a decade ago, a company in Waterloo, Canada released the Mile armband dedicated to EMG control. Brainco in Hangzhou has also tried EMG control of low DOF hands. So this isn't a new technology. Why are people paying more attention now? Because as algorithms improve, our ability to collect large amounts of data for training and fitting has improved significantly. So people are very curious whether new EMG methods can also faithfully and precisely reconstruct the pose and manipulation of each finger joint and the response to force.
Back to the hybrid approach, if it includes a whole forearm, how does it work with its downstream? The company's building full-stack humanoids.
For most approaches involving forearm tendon drive, as an aside, ICRA also had a company, Ryzen Robotics, whose tendon drive approach doesn't include a forearm. They put all the tendon drive into the palm, though that's another topic. For any approach that needs forearm tendon drive, the biggest issue is that you need deeper coupling and integration with the body maker. It can be swapped quickly like a fairly standard palm product. For example, Unitree's or Agibot's humanoids don't come with hands, so you can quickly switch to another company's dexterous hand. But for a dexterous hand company that needs forearm integration, commercially it more likely needs deeper integration and customization with the body maker. That's also why we've seen Zinova raise strategic investment from a lot of Chinese big players recently, because basically all the incumbents in their humanoid research have adopted a Tesla-like tendon drive approach for the hand.
I see Li Auto and JD have invested in them.
Right. I've talked with researchers at many Chinese big players, and for essentially all of them, choosing to follow Tesla's tendon drive path is a fairly straightforward choice, because they control the body themselves, and because Tesla is still pursuing this direction. Picking a different direction is a huge risk that a lot of engineers don't want to take.
Is that because they're big companies, there's pressure to report from higher ups, so the person in charge doesn't want to bear the risk?
You could put it that way. If Tesla turns out to be right, and you went and tried a new direction, who bears responsibility for that mistake?
Last time we talked, you personally favored the direct drive direction, but now, judging from the big players' moves and investments, it seems many of them are continuing with tendon drive.
For an independent, dexterous hand company, I think going full direct drive, building something that doesn't rely on tendon drive, may be the only or the better path, because if you need a deeply customized tendon drive solution, you'll most likely become a big player's bespoke supplier and struggle to independently become a standardized product company.
Speaking of which, another thought. If this company sits in the US ecosystem, set aside whether US manufacturing works, if it's a US company in a position of deep collaboration with the big players, it also has an exit path. It could get acquired by a big company. I'm not sure how feasible that is in China, though in autonomous driving there were some companies acquired by incumbents.
Yeah, but the acquisition prices weren't great.
Right, whether it's an exit at a good price, that's the question.
Right, whether you got acquired because you couldn't keep going or because you were doing extremely well, that's a huge difference.
So after this quarter's Dexterous hand developments, your preference between tendon and direct drive hasn't changed. You still think direct drive has more potential for now.
I think that judgment has actually strengthened because the latest breakthroughs in Dexterous hand research are still being achieved with full direct drive hands, whether Wuji or Sharpa. Fundamentally, whoever can supply reliable, stable, cheap Dexterous hands the fastest will become the de facto standard for this industry the fastest, meaning more of the algorithms and software get designed around your hardware architecture.
So right now, the two categories seem to have separate downstreams. The new direct drive companies' hands are more research market-facing, doing frontier dexterous manipulation model research, while the tendon drive approach, the Optimus approach, seems more industry-facing, even though when the industry side scales up may be a long way off.
Right. The most fundamental reason for the divergence is that Optimus hasn't publicly abandoned tendon drive. Fundamentally, Musk is someone who deeply believes in first principles, so he thinks a tendon drive direction is closer to the biological characteristics of humans, and is therefore a better direction, and he set a very high bar for the engineering team to push toward mass-producing a tendon-driven hand. But the reality is that his V3 hand has kept slipping, and when it can be produced at scale is still unknown. We've also heard different voices saying Optimus is trying alternatives, maybe direct drive, maybe hybrid. But we can understand that engineering exploration takes time, and a major shift takes a long process. For the vast majority of frontline engineers at Chinese big players, choosing a follow strategy, not just on the Dexterous hand, but on many other technical paths, like the body's algorithm architecture, following the overseas incumbents is itself a safer, more conservative choice. Because Dexterous hand research is still at a very early stage, it's hard to say the tendon drive approach the industry has chosen today is necessarily a direction that can truly mass produce and scale.
Now let's move into world models. The fourth and fifth developments, world models and VLA, both are directly tied to intelligence capability, the part people discuss as more squarely embodied AI models. Let's start with world models. After we discussed them last episode, it's become much clearer that world models are now a very hot startup wave, with a lot of new companies appearing in China, mostly serving embodied robotics or physical AI startups. Some companies founded just this year have grown into billion-dollar unicorns very fast, and several of the founders are very young. Let's start with the most important development you listed in this direction, NVIDIA's Cosmos 3. Can you give a quick introduction to what it is?
I think Cosmos 3 is the benchmark for world models this quarter, because it's arguably the first fully open-source Omni model on the market.
By Omni, do you mean unified or hybrid?
It means all capable. It can natively process different input modalities, text, image, video, audio, action, and output that same range of modalities, That's probably an industry first. By NVIDIA's own definition, Cosmos 3 is an all-capable world model that can be used for different prediction or generation tasks and can also output text, images, or robot actions like a normal VLM or VLA.
It has an important technical breakthrough called MOT, mixture of transformers. It's a two-transformer structure. One is an autoregressive transformer for reasoning. The other is a diffusion transformer for generation. From your conversations with researchers, how was the new architecture received? And were there any concerns or dissenting voices?
Conceptually, it should be a very ideal concept because for a long time we found that language model research and image or video generation research were two different architectures.
The latter mostly uses diffusion models.
Right. One type of model is better at discrete signals, text discrete tokens. The other is better at continuous signals. Diffusion is better at continuous sequences, images, video. For a long time, these two were isolated. In Cosmos 3, they used a very clever division of labor plus unification architecture. The autoregressive model is one independent transformer. The diffusion model is another independent transformer, but they share an attention mechanism in between, so their states can influence each other. It effectively stitches two very different modality models together.
And it unified understanding and generation, something people have been exploring and wanting to do. For it to actually work, was there some trick, or is it that they've achieved it structurally but the results aren't quite there yet?
What I just described is the architecture, a mixture of transformer architecture, where an input gets dynamically routed and processed by two pipelines. That's also why the model itself is fairly large. From the standpoint of architectural principle, I think it's very innovative.
Was it only with Cosmos 3 that they achieved this all-capable unification? What's the difference from the earlier 2 and 1?
There isn't actually a standalone Cosmos 2 brand. Cosmos first launched, I believe, at CES 2025, and over last year and early this year, it had an iteration that bumped those modules to version 2.0. Cosmos 3 is the new brand this time. Previously, there were several independent models, an independent predict model, transformer model, and reason model. This time, they essentially wove those models into one unified architecture.
My old understanding of Cosmos was that it's a video generation model, but with Cosmos 3, you can't simply call it a video generation model anymore.
It contains a video generation model.
Because it can also directly generate actions, right? Directly generating actions, in theory, that means it can be used on a robot, since robots need to generate action trajectories.
Right. So before Cosmos 3, there was a submodel called Cosmos Policy. It took the earlier Cosmos model and added an action head, so it could directly output robot operations. This time, they essentially unified everything. In NVIDIA's scope, this is a bigger picture. Cosmos 3 is optimized for NVIDIA's chip and compute platform, and NVIDIA also wants to push a robotics development kit.
It should also be usable in autonomous driving, right?
Right, because it's a general word model. This word model can just output different modalities. That's why it's an omni model. It can input all modalities and output all modalities. Only the activation level of the two transformers differs across combinations. For some modalities, maybe only the autoregressive transformer needs to be active to output, say, an image-to-text task, where that one is enough. But for a text and image-to-action and video task, it needs to activate the diffusion model below. From that angle, I think it opened up a great omni-model line of thinking, and I believe other big companies, including Chinese big players, will develop similar approaches later.
They'll follow this.
Right, because in principle, I think it's still a fairly elegant, fairly ideal architecture.
From Cosmos 3, we can move into the recently very hot world model space, which counts as a big startup and investment wave. Let's narrow the scope and just talk about world models related to robotics. Even within that, a lot of different things get called world models. How would you categorize them?
There are many definitions of world models. I'll use the categorization from NVIDIA's official world model survey written in June, which splits them into three types. The most foundational is the video world model, represented by Google's Veo and Alibaba's One. It's essentially a video generation model. Given some conditions or descriptions, I can generate the video, that is, an estimate of future states.
Right, they put Cosmos 3 in this category too.
Because Cosmos 3 is an all-capable model.
Video world models.
Right. On top of that, the next concept is the action-conditioned world model. Action-conditioned means its premise is based on your action, or a given action. You generate the world model conditioned on a given action.
So I add an action to the state, then predict the word's next state.
Right, and the action here specifically means a physical world action.
Because I see they put Dream Dojo, Genie, and Jepa in this category. I previously talked with the first author of Dream Dojo, Shenyi Wengo, a Gear Lab researcher, and the way I understood his description, Dream Dojo is essentially a world simulator.
It is a world simulator, but this simulator's input is your action, what you want to do, what change you want to produce. In training, this world model is based on its ground truth. The training material contains real physical changes and what impact they have on the environment. It's recording a lot of those changes.
Right, he told me there are quite a few action types. For instance, a text instruction he'd also consider a kind of action, though in embodied settings it's more often the robot's action that's the action, right?
Right, we usually say action means the robot's action, but a piece of text can also be an influence on the environment. From that angle, a pure video world model and an action-conditioned world model are similar in that you have some kind of input. It's just whether that input is a text description or a physical action. Walk forward, walk backward, pick something up, or change some environment. Take Genie. If you treat it as an action-conditioned world model, then a person's movement instructions in that space are a condition on what the world model generates.
And NVIDIA's third category is?
The World Action Model, WAM.
Right. WAM is the direction that's especially hot right now.
Right? The core is that we use this model to generate the robot's action, and maybe it also generates the future image or video.
So it generates both the future state of the world and the robot's action.
Right? So it's more of a policy. So whether it's Dream Zero or Ant Lingbot VA, they all fit this definition. In embodied settings, what we care more about is how the robot should respond and act.
So WAM is the hottest.
Right, it's the direction we are paying the most attention to.
Because it's used directly on the robot as a policy, right?
Right, but you can also see why Cosmos 3 is an interesting idea from the conceptual side. I've talked with some North American folks who work specifically on LLMs, and from their angle, they don't quite get why we invented two opposing concepts, VLA and world model.
They think it's one thing.
Or in their imagination, the best model should just be an omni model.
That's the Cosmos 3 direction.
Right? So I think Cosmos 3 represents, to some degree, an ultimate way of thinking about this kind of model as an intelligent model. It should take different modalities and output different modalities. From today's Cosmos vantage point, what it presents externally is one model. Internally, there's a mixture mechanism sharing states in different pipelines. But from the input and output side, it's one integrated model.
You said you talked with some LLM people who find it puzzling that these two things are set in opposition. That cues something you said earlier, like Gen 1 and Pio 7, which may both fuse some VLA and world model. So you think their narratives aren't really about one replacing the other, right?
Right. Or to get back to fundamentals, today's VLA is better at generating instructions and actions, while a world model, essentially a video backbone model, is better at predicting states. If we have a clever way to combine these two capabilities, the ultimate performance is surely better.
How do you see the current startup and fundraising boom here? I feel the turnaround was so fast this time. Dream Zero and results like it were, late last year? And immediately there were new companies with valuations and round sizes growing fast. Let's first take stock. Do you know which big world model companies are out there? Not necessarily specific to WAM, just companies in the investment market saying they do world models. Let me name the ones I know and you can add. The hot ones recently. Genesis as mentioned, and Liber AI too, right? Both are embodied AI companies. There's also Manifold AI, Inverse Matrix, and Moshi Shinkong. Those are the fast-moving ones I know of. I also talked with another investor, around early April, who told me someone had already compiled 49 world model companies. And there's a longer established one, Giga AI, probably the highest valued right now, founded back in 2023. The ones I just named were mostly founded in 2025 and 2026. These are all Chinese companies. Overseas companies, we touched on one last quarter, Rhoda AI, which announced a $450 million raise during GTC after having been in stealth for a year. Not long after we talked, I learned that Joel Zhang, the leader of NVIDIA Gear Labs Dream Zero team, a Korean, I may not pronounce his name right, also went out to start a company, founded in the US of course. There are some new overseas companies too, all in just the past few months. Anything to add?
I think it's hard to list every company. As I said, world model is a pretty big concept. Too many companies can slap the label on, so it's hard for me to judge which ones do pure word models versus how related their work is to word models. But what I can say is why word models are such a big shift or shock. Fundamentally, it's because we've seen the VLA approach, a video language model plus an action sequence hit a certain performance ceiling along that iteration path. Doing robot policy via the video generation route was actually attempted as early as 2023, including, as I mentioned in our last interview, ByteDance GR1 and GR2 work, early attempts at video action models. But because VLA could deliver a passing grade answer faster, with the typical example being the release of P0, itself open source and the SOTA of its time, a lot of teams followed it quickly.
Pine Zero was released in late October 2024.
Right. The VLA approach, abstractly, is essentially behavior cloning. We establish some association between a text and image description and a robot motion signal. If a person repeatedly demonstrates an action, we can definitely build some association that lets the VLA output similar robot joint signals. But this route's generalization limits are very obvious. The video generation route, by contrast, can tap far larger, more massive data know-how, which also contains a lot of physical priors. So in principle, this route is inherently very attractive. It's just that in 2023, when we first started trying, you didn't have a good video generation model. You didn't have a well pre-trained decent open source model like one. And you didn't have things like the diffusion policy we later came up with, using diffusion to generate continuous joint sequences, nor flow matching. Those may have only gradually matured in 2024 and 2025. So a lot of the basic recipe for world action models existed 3 years ago, but the capability only gradually got unlocked at the end of 2025 and start of 2026. From my own view, why do I find this so exciting? Because today's SOTA video generation models, Kling, Cedance, Veo 3, have reached a very high level. Their understanding of physics and common sense is in a good place. If I use them for robot prediction and policy, in theory I can get great results. So I think the arrival of this set of ingredients is why the concept suddenly exploded in 2026.
If this technical progress excites you, a happy feeling, then seeing so many companies raising so much money, as an investor, how do you feel?
Fundamentally, it's because people made money in large models, so those who made money will pour more in, and those who didn't will also pour money in on this wave.
Those who made money keep investing, and those who didn't are buying a late ticket. Plus, embodied AI is a big direction, so any new technical stimulus draws investment.
Right, that's the underlying element, and it's why valuations can rise so much in a very short time. But over a longer horizon, first, in embodied AI, whether hardware or models, Chinese companies have very good resources and capabilities, and it's a long-term strategic direction with a lot of national support and strategic investment for startups aiming to become world-class companies in this field. It's a great opportunity, and investors see that opportunity too. Whether this turns out like the EV wave, where maybe 100 plus companies each got founded to make EVs, I don't know, but a big wave definitely brings a flood of talent and capital. So this wave also reflects just how violent the change has been.
The last top 5 development is VLA, which against the hot world model trend, looks a bit dated by contrast. You mentioned 2 specific developments, both appearing between early and mid-April, Physical Intelligence Pine 07 and Generalists Gen 1.
Right? Whether or not we slap a VLA label on them may not even be what matters most. I mention them because I think they're existing model companies that made fairly inspiring and innovative breakthroughs this quarter.
Let's take them one at a time. For Pine 07, what insights did you take away?
First, I think Pine is a very innovative, steadily iterating company. From 05, 06 to 07, each version's iteration is very clear. At 07, if I had to sum up the biggest difference from prior versions in one line, I'd say, on top of a traditional VLA, they attached a lightweight world model. This lightweight world model provides image predictions of future tasks and uses those predictions to influence the generation model in producing the corresponding actions.
This lightweight prediction means, say my hand has only moved to this position. Suppose I'm reaching for this cup, and when I've only moved to this position, it can predict
what the next few frames should look like. It generates that.
Like the positional relationship between the object and me, or its deformation.
Right. Then, from the result image I've judged for some near future moment, you use that image to guide your action generation. It's like a very lightweight, somewhat predictive future sub-goal image fed back into the VLA's generation process.
This actually fits human intuition pretty well, because for a lot of things you can roughly imagine how it'll go, you just don't execute that precisely. There's a class of actions you obviously picture first, Like when you're about to throw something, say tossing a paper ball into a wastebasket some distance away, you picture the trajectory.
Right, well put. Our mental picture, what force, what angle might lead to what result, so we adjust our angle and force based on that mental picture. Back to Pio 7, I think Pi has been leading the frontier of VLA research. As we mentioned last quarter, at 0.6 they introduced some new capabilities, including something like long-horizon agent planning, using a text logging method to continuously store the current state, then planning the specific actions to execute based on previously observed states. Lots of these small improvements in each Pi version feel very innovative or industry-leading at that moment.
Then let's talk about Generalist Gen 1. My own gut sense is that among Chinese practitioners, there's more discussion of Gen 1 than of other models.
Right, it drew more attention. I think it made a few clear breakthroughs. First, it significantly sped up the execution of VLA models, which people felt were slow, no more plodding through a task. Second, on some fairly complex long horizon tasks, they claimed very high accuracy. For several tasks, average success went from the low to mid 60% up to 99%. That jump reflects a significant leap in their model's task capability. Another point people pay a lot of attention to with GN1. They collected 500,000 hours of real-world interaction data themselves, a WUMI-type embodiment-free collection, a very efficient method, and they used that 500,000 hours to train an end-to-end model from scratch without a pre-trained VLA base. I think that reflects the team's high confidence in their own technical path, and that their model has fairly strong scaling capability, letting them use this much data. And in their reports, they also clearly showed that across different data scales, 10,000 hours, tens of thousands of hours, up to 500,000 hours, generalization and capability both improve significantly.
This is essentially demonstrating whether scaling law holds here.
Right, or by generalists' own claim, they've always said they found the key to scaling law.
You said they didn't fine-tune on a VLM, which shows the team is very confident. Is that because the approach is rare?
I think in research, people easily fall into path dependence, especially once a method proves somewhat effective. Typically, many Chinese model teams, because Pine is open source, will do a lot of post-training and fine-tuning on top of Pine, and like to use it as a benchmark to claim, I improved on Pine 05 by such and such performance. On one hand, that shows Pine's influence in setting or leading industry standards. On the other, it shows that independently pioneering a new technical approach, investing this much data to collect and train, takes considerable courage and resolve.
So for two US companies, Generalist and Pine, Generalist wouldn't be caught copying anyone, and these teams are too proud to follow each other.
This is my overall observation of the US venture ecosystem. The US venture or startup environment overall rewards innovation enormously. You rarely see 2 or 3 teams telling the exact same story. Most teams find ways to differentiate technically or in approach, and investors reward whoever does it first. Fundamentally, the US has many very active giants, and the giants themselves run a lot of innovative work with their own frontier labs. A lot of great work comes from companies like Google, Meta, and Amazon.
Right, including all the NVIDIA mentions when we discuss embodied AI.
Yes, so for a hard tech startup in the US, in the market's inertia and investors' minds, if you can't do something highly differentiated and innovative, you struggle to gain momentum, to win market and investor recognition, and to get acquired. An acquisition by a big company is a perfectly normal exit for a lot of US hard tech startups. So I find that in the US, not only in embodied AI, but in many fields, you'll feel some companies may be innovating for innovation's sake. Because in the US, big company innovation itself is effective and competitive, so if you only do something cheaper or the same thing, it's hard to win customer recognition or product premium in the US market.
Back to Gen 1 specifics. Earlier you mentioned Pine 07 added a lightweight world model. From Gen 1's public information so far, can you tell what generalists' thinking on world models is?
From the public information, they're actually fairly resistant to defining themselves as a world model or a VLA. Peter Florence wrote a whole piece, the gist being that their approach is neither gluing actions onto a VLM to make a VLA, nor a world model. Rather, their model is trained entirely on native physical interaction data. That's why the hundreds of thousands of hours of data they collected can be used directly to train a transformer network without depending on a VLM or a video generation model as the backbone.
So it's their own method, and since they've never open sourced it, outsiders don't know the details.
The specific details, no. But the same line of thinking, since these people came out of Google, was actually shown in Google's earliest pioneering work, RT1.
RT2 is actually the starting point of the VLA wave.
But before RT2, RT1 essentially trained a mid-sized transformer model. Its input was text descriptions, some action images, and some joint sequences, and its output was online joint sequences based on those text descriptions. The backbone of that model was an independently trained transformer model.
Speaking of RT1 and RT2, interestingly, this quarter Gemini Robotics also released a new model, ER 1.6 in April, but you didn't put it in your top 5. How do you see Google or Gemini Robotics in terms of results and influence in this space right now?
Google's Gemini Robotics is still a fairly large division pushing a lot of research. The recently released ER 1.6, full name Embodied Reasoning 1.6, you can think of as a better VLM model. It can't directly output robot control or policy.
So it's not a policy model, not used directly on robots.
Right, it's a VLM that provides more spatial and task understanding and reasoning. It can better describe and reason about physical environments or conditions through images, video, vision.
Behind it is Google's ecosystem-level thinking on embodied AI. They want to be the Android of this field. So when ER 1.6 launched, they mentioned some partnerships, one carrier being Boston Dynamics Quadruped, the Spot Dog. Another partner they mentioned was one you brought up last time, Anthropic, where you said their development with Google had some delays, and another is Agile Robots Humanoid, Agile 1. It looks like Google wants to be the Android of robotics. Do you think that approach has a market now?
I think Google definitely wants a brainish, API-ish, software-ish position. ER 1.6 is showing they want to leverage their language model strengths, add high-level spatial reasoning and understanding, and package it into a product that can be called and used. Actually, if you read the ER 1.6 report, its comparison baseline is directly against the Gemini Flash 3 model.
So it's compared against the general purpose model.
Yes, it is a general purpose model, just one trained with more understanding of physical environments. The Boston Dynamics partnership you mentioned, industrial inspection, is a very typical work scenario. The Boston Dynamics Spot Dog, last I knew, shipped a few thousand units, genuinely used in industrial inspection. Fairly complex oil and gas field settings where the dog needs to climb stairs and navigate complex terrain. In those oil and gas facilities, the main purpose is to inspect all kinds of traditional valves and the numbers on panels.
The numbers on the gauges.
Yes.
So the Boston Dynamics dog both reads these numbers and checks for any anomalous values.
So I think ER 1.6 is essentially a general purpose model, but with added spatial understanding, and it represents the big players' thinking or attitude toward this problem. If they can solve it with a general purpose model, then ultimately they may really just need to train one omni model to solve everything.
What do you think that means for small companies? Right now, it looks like Google has quite a few partnerships with small and mid-sized startups.
The few companies it partners with now are relatively more on the robot body and hardware side, so there's a natural fit between them. I think the more fundamental question is, what reason do we actually have to believe that? Years from now, the models for so-called embodied AI won't come from general-purpose model giants like Anthropic, OpenAI, or Google. If the omni-model path ultimately proves effective and useful, then can all of a robot's spatial understanding and action prediction be folded into a single larger general-purpose model?
Because this gets debated a lot, one opposing view that comes to mind immediately: forming this kind of model requires a lot of hardware participation, hardware to collect data, and many general-purpose model companies just don't do that part, or are very bad at it.
They may indeed be bad at it today because they haven't optimized for it. But in reality, we also know that large model companies have spent billions, tens of billions of dollars on labeling all kinds of corpora and data, just mostly text and image data.
Speaking of which, OpenAI did more formally announce their robotics team at the end of May. Sam Altman put out a tweet with a few keywords. One, they're looking for top full-stack talent. He listed a bunch including hardware, systems, machine learning to make robots useful for society. The second keyword was scenarios. He mentioned the near-term use case is building infrastructure for their own use, presumably AI compute infrastructure. Long-term, the vision is pretty mass market, a robot everyone might use. He also mentioned some technical evolution clues, like the team's leader being Aditya Ramesh, who's led it over the past year, gradually evolving into OpenAI robotics. I looked into his background. He's the author of DALL-E, and went straight into OpenAI after his undergrad at NYU without doing a PhD.
Right? My understanding is that OpenAI's robotics team was built on the team that previously did DALL-E and Sora, the image and video generation team, or that's their technical foundation. Internally, OpenAI's positioning or interpretation of Sora has always been that it's a world model.
They said so from the very first release. And I'll add, this person, Ramesh, the team he previously led, the name written on Twitter was World Simulation Research.
Right. So I think OpenAI robotics being founded so high profile today is precisely because they saw the inflection point or breakthrough in this set of technologies.
How much do you think they'll invest in this? Because for a while, Anthropic's very strong growth with Claude Code and Claude Cowork put real pressure on OpenAI. So at one point, it looked like they shut down Sora 2, a kind of contraction and refocusing. And in Q2, they announced this new robotics team would formally start hiring more people. Will they really treat it as a key priority?
Let me share an observation. Even today's largest embodied AI research teams, the compute and model scale they actually touch is a very small order of magnitude compared to flagship video generation models, let alone flagship language models.
For instance, Gen 1 is said to be 500,000 hours of data.
It's not the data volume difference, it's the actual compute used. Take Cosmos 3. I think it already represents the highest compute budget invested in training an embodied AI model today, roughly 10,000 GPU scale, which is the ceiling of compute for embodied research today. So by that standard, for OpenAI or Anthropic, top LLM companies, it's not a particularly large compute budget.
You mean they don't even need to treat it as a major priority? It's already more than most embodied teams invest.
Right? Or a comparable analogy is Anthropian team, LeanBot VA is probably also around the 10,000 GPU level.
I have another question. He wants to do it full stack now.
Because robotics research can't be separated from hardware. Frankly, research is still very early, and precisely because it's early, if you detach from hardware, your research is hard to validate, so you have to stay close to hardware for research to be efficient. What I know is that OpenAI will make the Dexterous hand a very big investment and research direction. They're entering this market so they can't go back to grippers.
What chain reaction do you think OpenAI's move will trigger next?
I think OpenAI being able to high-profile restart the robotics business at this moment also shows they saw the technical maturity and its relevance to their core model capability. We know they shut down Sora's consumer product API in April, but in reality, a lot of robotics core members came from the Sora team because Sora's original goal was to be a world model or to have world simulation capability. So I think OpenAI's investment here will be fairly similar to and correlated with the world model line we've been tracking. Given that they have substantial compute and can attract some top researchers, I'm still looking forward to them delivering industry SOTA progress in this field over the coming period.
Finally, let's talk about some changes and important events not covered in the top 5, including capital markets and commercialization. One clearly important event is Unitree's IPO. We discussed its prospectus last time, including Unitree's history and its special position in the industry. In Q2, it formally cleared the Star Market IPO review and will soon see it list. After this first batch of leading companies goes public, what do you think happens to the companies behind them?
I think Unitree's listing is a landmark event for both the development and the investment side of embodied AI. Fundamentally, it sets a valuation anchor for all of today's leading embodied companies, and the others will use it as a valuation baseline. There will definitely be very large companies in general-purpose robots because a humanoid is inherently a very general product, so the odds of growing a really big player here are higher. But because humanoids still face plenty of physical constraints today, power density, motor density, battery density, weight, volume, even after humanoids become widespread long-term, we may differentiate into different humanoids for different scenarios, small robots in entertainment, performance, even research, large robots in use cases needing heavy load hauling or large but low-speed payloads. So I think humanoids will diverge somewhat in the future, meaning the body isn't necessarily winner-take-all, but the brain could be.
That's what you said, if the Omni model path holds.
If one supermodel's capability is significantly higher than everyone else's, we've already seen a very strong early sign of this with Anthropic. It may not be winner-take-all, but it's at least an oligopolistic phenomenon. The more fundamental issue it reflects is, as an intelligence product, the brain, I think intelligence is necessarily bimodal. Either I pursue the best intelligence, or I pursue okay enough intelligence. Under that bimodal assumption, and given that a model is itself a low marginal cost product that can be open sourced and shared, then long-term intelligent models will most likely split into high-level open source models and top-tier closed source models. If that's the pattern for language models, I think the endgame for embodied models is very likely the same.
High-level open source models, top-tier closed source models.
And no room for other models to survive. If a closed source model can't beat the SOTA open source model, it has no reason to exist.
So who provides the high-level open source models? Big companies that want to build ecosystems like Google and NVIDIA.
Very likely, yes. In language models, isn't it currently companies like Qwen and DeepSeek providing them? When we discuss this with model company founders, there's an ultimate question I find pretty hard to answer.
Are you talking about founders of large language model startups or embodied AI model ones?
Embodied, but I think it's the same question. If you build a model startup, how do you answer two competitive questions? First, how do you compete with the best open source model, which is most likely provided by a company like NVIDIA, because its business model doesn't depend on monetizing the model but on monetizing compute, so it can open source the model. Second, how do you compete with the oligopolistic top-tier private models, whose supply most likely comes from Google, Alibaba, ByteDance, Anthropic?
Have you heard a founder give you a fairly convincing answer?
This question was asked repeatedly of Anthropic by investors back when it was founded, but Anthropic became Anthropic.
You mean when Anthropic was just starting out, it couldn't necessarily answer this either. So whether you can answer it at the start isn't what matters.
Right, OpenAI probably couldn't answer it either, at the very beginning.
But when they were founded, they didn't face a crowd of large language model companies the way embodied AI models do.
Objectively, I think today's embodied AI startup and investment boom is connected to the success and boom of the previous wave of language model startups. We already have several large language model startups that successfully IPO'd, with more in the pipeline creating handsome returns for investors, so it's reasonable to infer that embodied models may hold the same startup or investment opportunity. But the challenge is, if everyone thinks this way, the market will definitely end up in overcompetition and overinvestment. The eventual winners will still be scarce, and expected returns or expected odds of startup success get heavily compressed.
Unitree, as China's first embodied AI company to go public, has actually been profitable for years, but most other companies aren't. They're still in early stage exploration. A question the industry debates repeatedly is how the pace of commercialization and deployment will play out. Some of the top 5 developments relate to this, like Robot Era's China-Post partnership. More broadly, on deployment pace, do you have any new thoughts this quarter?
On deployment pace, I think you have to look at two dimensions: the China-US difference and the difference between hardware companies and model companies. Take the leading US companies, whether OpenAI or today's physical intelligence. They fit a typical pattern of a US frontier field innovation company, a group of very smart, visionary people or scientists coming together to invest continuously in a hugely promising but long uncertain direction. The US creative environment also offers a good early incubation phase. For instance, from OpenAI's founding in 2015 to late 2022, before ChatGPT, it had no obvious commercialization or productization progress, but that didn't stop it from absorbing huge talent and resources to pursue the goal. Today we see physical intelligence doing the same thing, continuously releasing, even open sourcing their leading models, leading the industry. But on deployment, so far we haven't seen a clear timeline for when it can truly reach commercialization or deployment.
You mean these US companies?
These US companies, basically every US company has this issue now.
Except Figure seems to talk about it more.
Figure also has no confirmed, truly validated deployment revenue right now.
But at least it puts on the posture of, I'm going to deploy.
A posture, right? And I think posture and reality are pretty different.
So do you think Chinese companies are already at reality, not just posture?
I think fundamentally, in China, people have very low tolerance for this kind of very long-term, uncertain exploration. So you need to put on this posture even more and ideally make it a reality. The challenge in China today is, if I step out and say, I'm building a company and clearly tell investors that for 10 years, I absolutely won't commercialize, absolutely won't deploy. The problem is, how do you get enough resources, attract enough talent, get a good capital market response, and even deal with the future resistance of tapping the secondary market? How do you solve those challenges?
One option, already be Wang Feng Liang, be rich enough to begin with.
Exactly. So I've always thought DeepSeek is a very scarce, very different company. When you're successful enough yourself and have enough faith in the thing, and objectively, OpenAI and DeepMind were originally a group of billionaires attempt an investment. OpenAI was originally a non-profit, and at least for a long stretch at the start, commercialization and profit simply weren't its goals. So I think the bigger disagreement today is about what stage we believe embodied AI's research and industry development has actually reached. If today I had a crystal ball and told everyone this is like autonomous driving, needing at least 10, even 15 years to reach scaled commercialization, let alone profit. Waymo achieved commercialization, but Waymo isn't profitable yet. If I told people it takes 15 years to be profitable, would anyone still be willing to start companies and invest in this field? Whereas if we judge it can commercialize and turn profitable within 5 years, then more people would be willing to invest and start up. So a very fundamental issue is that people's judgments about this cycle may differ.
For now, your own judgment, is the timeline shortening, lengthening, or not changing much?
Compared to last year, I think the cycle is definitely shortening. Fundamentally, this is an important enough problem that it has gathered huge resources, capital, and talent across society and the market, including why there's been such fast development of world models and a whole set of technologies. It's because the foundational ingredients are maturing fast, and because progress in related fields like language models lets a lot of capability, compute, and data migrate into embodied AI. So in reality, those facts have accelerated embodied AI's development. That's why in this quarter's developments, we singled out Figure and Robot Era doing humanoid courier sorting, because we at least saw that in such a scenario, a general-purpose humanoid using the new algorithmic tech stack can solve the problem better with real deployment potential.
Finally, let's look ahead to next quarter, or the next stretch, for changes in the industry. We also reviewed the 3 things we forecast last time, which largely kept happening in Q2. Looking further out, what new things will you be watching?
One thing I've been mulling over, which I think will become more mainstream, humanoid robots as a form factor and carrier. Over the next quarter or two, there may be more humanoid products getting deployed and commercialized in specific scenarios, and more companies entering the market, announcing their humanoid product plans or roadmaps.
The more companies you mean aren't necessarily startups, you mean some big companies, in China and abroad?
Right. Of course, from announcing a plan to releasing a product, I think there's at least a year to a year and a half.
People will differ on this timing. For instance, talking with some embodied founders, I find they judge the timeline as more urgent. They think the big players will enter faster. Take Li Shan, even though he announced this around early 2026, internally they'd probably been at it for a while, including Honor, which has actually had 2 years on it.
Right, but not all big players. My guess is that the next quarter or two or the next 6 months is the last window to enter this game. Because if you don't start and enter this market in 2026, then by 2027 or 2028, when humanoids really start to deploy widely, you have lost your head start.
The really large device makers, phones and cars, at least the mainstream Chinese ones, I feel most have laid some groundwork. There's another type of big company, the large internet players like ByteDance, Tencent, Alibaba. I mean on the full stack humanoid direction, what might they do?
For these incumbents, I think the better benchmark is the model and approach of companies like Pine and Anthropic.
So still leaning toward an intelligence capability foundation.
Yeah, because they're so good at building models, a model's business model and capability are highly correlated with their own strengths. That's why among China's large language models today, ByteDance and Alibaba are very much in the lead. I think doing embodied AI startups in China has a paradox or an awkward spot beyond what we just stressed, that you can hardly build a company in China with no commercialization and no revenue for 10 years. There's another point. Investors or China's capital market also find it harder to tolerate a company that isn't full stack or that has a lot of capability dependent on other customers.
And the partners.
Right. The result of that, which we're already seeing, is that all the embodied brain companies are announcing they're building robot bodies.
On that note, a while back I interviewed Huaze Shu, who has a very non-mainstream view. He thinks not everything should be done in-house, some things should be left to the ecosystem.
I think that may be right, and it may also be a very American way of thinking.
He surely also believes intelligence capability is the priority over commercialization.
From his founder's vantage point, only if you can be the industry's best at any one thing does it have meaning.
You mean if you don't do full stack?
If you don't do full stack, or your timing for full stack is already too late, you don't have a great position to go full stack, then being the industry's best in your niche is valuable. I think the ultimate big winners will most likely still include full stack companies. Apple, Xiaomi, Huawei will exist in the embodied era too. But here's an interesting point. Today, the biggest companies by market cap aren't actually full stack. Nvidia isn't full stack. Anthropic or OpenAI, if it eventually IPOs, probably can't be called full stack either. So is full stack the endgame, or is vertical integration the endgame? I think this will swing back and forth for a long time. It's essentially a relationship of competition and gaming. But in the China market, the hard part for startups, I think, is you can hardly say you'll have no revenue for 10 years. And second, you can hardly say you'll only be a brain company or only a body company. Including a challenge many investors raise about Unitree, that Unitree is just a hardware company with no AI, no model. I don't really agree with that challenge, but the market does have a lot of people who use it to attack Unitree.
That's a great example. Even as strong as Unitree, in one segment, it still gets challenged for not being full stack.
Right. If we assume Unitree stays a hardware company forever, then I think it's also a very profitable hardware company. Whether it can form a monopoly may be a second question. But I don't see any reason it can't grow its own software or AI layer if the company genuinely wants to strategically and directionally.
Okay. Thank you, Peter, for joining LateTalk again and sharing the new changes you observed in embodied AI in Q2 2026. At the end of this episode, we looked ahead at what might happen next. In the Q3 and Q4 episodes, we can come back and see whether these developments get borne out. Bye, everyone.
Bye bye.